All right, guys. So for today, we are going to look at different ways to factor. Yay! Today, we are going to focus just on factoring with the new ways. Tomorrow, we'll focus on factoring and then solving, okay? Because some of them get a little complicated in the solving. All right, so just factoring today. So always remember to factor out the blank before doing any other factoring. GCF, greatest common factor, if you want to fill in the whole line, if that bothers you. I'm just lazy and I write GCF. I'm going to tell you right now, most students who mess up these new types of factoring, it's because they don't pull out a GCF before they determine what type of factoring it is. Okay, so you have to pull that out first. So after that gets pulled out, you're going to have to look and see what you have left. It's going to be based on what pattern it fits. It's either quadratic. What's quadratic mean? X squared. So it's either x squared, which is our normal factoring, quartic, which is x to the fourth, factor by grouping, that will have 4 terms, and we'll get to that, and then sum or difference of cubes. Any guess there? That's x to the third, and it will only have 2 terms. So it's like we have difference of squares, my favorite, right? Or we can have sum or difference of cubes. Both of those have just 2 terms in them. So we're going to learn how to do all this today. Gotta love factoring. It's an exciting day. All right. So first, use guess and check to factor quadratic trinomials. So this would be in our form of ax squared plus bx plus c equals 0. Okay, so this is just we're starting off with stuff we know. Just a regular old factoring. So how would you factor number 1? What do you do first? Take out 2x. Because if you look at the original problem, is it in the form ax squared plus bx plus c? The original problem is not ax squared, it's ax cubed. But as of to this point, you would never even stop to think because we've never learned any other factoring yet. But this one, once I pull out my GCF, then I have x squared plus 4x plus 3 left over. Now it's in that form. It's my ax squared plus my bx, my c. But we have to pull that GCF out first to turn it into that form. Okay, and factoring further, what are your signs? Both plus. Options for A, it's just x and x. Options for C, it's just 1 and 3. Notice there is no equal sign. We are not solving today, just factoring. Okay, number 2, GCF. X cubed. Okay, the original problem is an x to the 5th. I don't know how to factor x to the 5th, right? Everything we factored is ax squared and then bx and then c. But when I pull out the GCF, we have 2x squared minus 5x minus 3. Now what I have left is the form that I'm used to. Okay, factoring further, what are your signs? Positive and negative, good. Options for A, 1 and 2, so 1x and 2x. And options for C, 1 and 3. So if I check that, just in the order you said that, that gives me negative 1x. Flipping the sign is going to make that a positive 1x. Flip the numbers. Yep, we need to flip the 3 and the 1. All right, so then if I check, I get 6x minus 1x, which is a positive 5x. Now I need to flip my signs. There we go. Now it's factored and it works. All right, what about number 3? GCF? 4 doesn't go into 18. Oh, thank you. First one's negative. Take that thing out. So negative 2x squared. So what is left when I take out a negative 2x squared? 4x squared plus 9x minus 9. Remember, dividing out that negative is making all your signs flip. So what are my signs then when I factor further? They are opposite, 1 plus, 1 minus. Oh, do you want to go 1 and 4 or 2 and 2? 2 and 2, okay. 2x, 2x. 1 and 9 or 3 and 3? 3 and 3. She's like, wait. You check that, we get 6x minus 6x, and that canceled out in the middle. That is not what we want. So, are we switching 3 and 3 to 1 and 9, or 2 and 2 to 1 and 4? 1 and 4? All right, so 1x and 4x. So that would give me 12x minus 3x, which is a positive 9x. Yay! That works. Isn't that great? All right. Regular old factoring. But do we see how the original problem was not in the form that we're used to until I pulled that GCF out? Then I can recognize that x squared going there. Okay? We have difference of squares, my favorite. So number 4, looking at number 4, does it look like a difference of squares? No, that's an x cubed. But what do I have to do first? GCF, which would be even more than just x. 3x. Once I pull out the 3x, we have 4x squared minus 25. Now we can see that it is a difference of squares. That's an x squared left inside there. Okay, factoring further. Those are my favorite ones. How does it factor? Thank you. 2x plus 5 and 2x minus 5, because I always like the positive first. Apparently you and Carson don't, but that's okay. Okay, number 5, GCF. Four x squared, good. You guys can talk to me. Some of you are like holding up fingers, but like so quietly. You can talk to me, it's okay. All right, so take out a 4x squared. And we're left with x squared minus 9. Again, make sure you're careful. The original problem looked quartic, but pull out the GCF. My problem was actually squared. And then how does that factor? Plus and minus, sorry? Your brain was solving the same time you were doing that. Good. And then number 6, GCF. Good. Negative x to the cubed. All right, take out a negative x cubed. What do we get? Plus 1. Okay. Factor further? No, it wouldn't. Yeah, we got a sign problem going on in there, huh? If that was a minus, we could keep going, but there's not, so actually, we're going to stop there. All right, questions on the stuff that we've done before. The biggest thing I need you to recognize is don't determine what type it is until you pull out a GCF, okay? All right, so let's talk about some new stuff. What if it is not quadratic? Can it still be factored? And the answer is yes. So the easiest ones to factor next is you will factor quartics, right, x to the 4th, like you factor quadratics, which is x squared. Okay, so like your original problems was like ax squared and then bx, right? It like went from a x squared to an x to the 1st. Notice these go from an x to the 4th and then to an x squared. See how they kind of still cut in half, right? Before was ax squared plus bx plus c. It went from a squared to an x to the first, cut in half. X to the fourth goes to an x squared. It cuts in half. So it's the same kind of pattern. So for this one, there is no GCF. I'll set up my parentheses. Still following the same sign rules. My last one's negative, so plus minus. Options for A. Instead of x and x, it's going to be what? X squared and x squared. All right. And then options for C. 1 and 4. 1 and 4. Now, just to make sure we're okay on how this comes together as a 3x squared, if we check this, we get 1x squared minus 4x squared, which is negative 3x squared. Okay, so we do get the x squared when we actually multiply those together. Now, am I done factoring, though? Look at this. Can we find something that factors further? 2 terms. That's a square. Minus sign, that's a perfect square right here. What is this? It's my favorite. How does x squared minus 4 factor? Good. X plus 2, x minus 2. Does the x squared plus 1, does it go further? No, it's got a plus sign in there. Had that been a minus, then it would have. But it just drops down. If I would multiply all this back together, I would go back to where I started. I can check it by doing that. All right, but x squared plus 1, x plus 2, x minus 2. So anytime you get a parenthesis that's got an x squared in it, just look and see if a difference of squares just kind of jumped into your problem. They show up sometimes without you even realizing it. All right, number 8. Is there a GCF? No. Now this is a quartic, right, because it's x to the fourth, but it's just like our quadratics. We factor them the same way. So set up your parentheses. What are your signs? Both plus. All right, options for A. We got 1 and 18, 2 and 9, or 3 and 6. Over here, we're going to have 1 and 2. All right. So what are we thinking? 3 and 6? Okay. So it'd be 3x squared, 6x squared. That way when you multiply them together, you get back to the 18x to the fourth. All right, and then 1 and 2, I know 2 cannot go with the 6. So it looks like that. Checking, that would be 12x squared and 3x squared, which is 15x squared. So that one worked. Did I end up with any difference of squares hiding in there? No. Difference of squares has to have a minus sign, so I don't have to look any further than that. And we're done. You don't like the next one? There's a lot of variables going on in there. All right, so on the next one, is there a GCF? No. That one only has an x to the fourth, and that one's only got a y on it, so no GCF. All right, but is it still like quartic, right? It's x to the fourth. So what are my signs? We'll start there. They're both plus. Options for A. 1 and 1, so x squared and x squared. Options for C. Just 1 and 5, right? But what else is going to attach to the 1 and 5? A y squared. So 1 and 5, but that's got a y to the fourth, so it's going to be a y squared and a y squared. Same way the x to the fourth split apart, the y does the same thing. It just happens to be attached to the end. And again, if we check this, kind of see what happens to that middle, that's going to give me 1x squared y squared. The outside is going to give me 5x squared y squared, which together makes 6x squared y squared. Okay, so those x's and y's do come together when we check this one to make sure it works. So far, how are we doing with quartics? They're very similar to quadratics. Just watch for the difference of squares that shows up. All right, moving right along. Same idea, factoring quartics like we factor quadratics. But these are like my favorites. All right, so you're going to have the 2 terms. and you have an x to the fourth, and they are perfect squares. So how did this first one factor? Good. Same way I did the last one, right? My favorites, except instead of x and x, it's x squared and x squared. Okay, number 11, GCF. 7. So we have 4x to the fourth. Some of you are losing this last part here. Minus 1. Number 7 divided by 7 is 1. Okay, so don't lose that extra term there. All right, is that a difference of, kind of like difference of squares, but it's difference of cortex? It's not as fun to say. All right, so we separate that one. How does that one break down to factor then? It is, yep, 1 and 1. Yep, you already put the plus and minus in. Good. Ooh, does this one keep going? Why not? The 2's not a perfect square. Had that 2 been a perfect square, it would have went again. Okay, so watch those x squareds left over. They sneak in on you and make you lose points because you forget about them. Number 12, GCF? No, one's an M, one's an N. Okay. How does it factor? And now the second part? Good. 3m squared minus n squared. Ooh, does that one keep going? Why not? Because of that 3. Good. What? Oh, it's still factor cortex like you factor quadratics. Same idea. All right. That's the easiest part of today. How are we doing? Because really, that's not a whole lot new. All right, so let's get into some stuff that's like different. All right, what if you have 4 terms? So far, we factored with 2 terms as difference of squares, right? 3 terms is our ax squared plus bx plus c. But now we're going to have 4 terms. Most people like these. In fact, this is how Lexi factors everything she does. You turn everything into this. The way that you factor, you turn everything into factor by grouping. So you know how to do that. All right, directions. So right on here, if there are 4 terms, it's called factor by grouping. You will literally group the first 2 and group the last 2. Okay, just sticking them in parentheses. Factor GCFs out of both. And then the actual factored answer is there should be a common factor left over. That goes in one parenthesis. And then the leftovers, and I'll explain that, goes in the other. So you will still end up parenthesis, parenthesis, just like we always do when we factor. All right, so number 13, looking there, we are going to group the first 2 and the last 2. Don't lose that sign on that third term in. Make sure it still stays with it. Now, I am not factored right here. Ruben, you alive? You awake? He looks really tired. All right, so it says pull out the GCF from each. GCF in the first set is x squared. What do we have left if we pull out an x squared? 2x plus 1. GCF in the second set? Negative 9. Good, that same rule about that first term being negative, we need to pull that out. What's left when you take out a negative 9? 2x plus 1. Wait a minute. I said there should be a common factor. Do you see a common factor? You should. See the 2x plus 1? So what you're actually doing is you are factoring out the common factor. So the common thing between these is 2x plus 1. And if I factor that out, what are you left with? Pull that out, you are left with x squared minus 9. Everybody with me? Cool, right? But am I done? X squared minus 9. There's that difference of squares again. How does that factor? X plus 3. X minus 3. And that 2x plus 1 just keeps coming. Will I always end up with a difference of squares that keeps going? No, I won't. That just happened to be one that happened. It doesn't always happen, though. All right, 14. Let's try it again. See how there are 4 terms, right? So first set, second set. I will tell you right now, this is the only type of factoring that I'm okay, and I think it's easier if you don't pull out a GCF first. Because do you see that this one does have a GCF? 2x actually goes into all of them. And I used to like make kids pull that out first, but I think he gets lost in the way. And now I think it's easier just on 4 terms, pull him out at the end if there is one. Okay, otherwise he gets lost. All right, so here we go. So what's a GCF in the first set? 2x cubed. Okay, what is left when I pull out 2x cubed? X minus 2. What is the GCF in the second set? Dustin. Got sleepy boys today. Just 10x? Negative 10x? All right, taking out a negative 10x flips that to x minus 2. Careful of your signs. Do you have a common factor? Yes. See my common factor? I'm going to pull out the common factor of x minus 2. What's left over when I pull that out? 2x cubed minus 10x. So that is the actual factor by grouping part. Now, just like this one then had something that went further, this one does too. See there's a GCF sitting here? Let's pull that out. GCF on that one is 2x. So we'd have x squared minus 5. Thank goodness that wasn't a perfect square, right? I got too close. All right. What do I do with the other stuff? What do I do with that? I drop it down. Should I drop him in front? Would it look awkward? Yeah, it's not wrong. It just looks awkward. I'm just going to throw him on the backside. Hello, board. All right. Now, I want to make sure we're understanding this process, because what I get every year from students is they get to this point, some kids stop here. They're like, yep, factored. Yeah, no, it's not factored. Okay, or they go from here to here, and then they tell me that they have 2 of these. Because they're like, well, I got 2 of them. No, we don't have 2 of them. Okay, if I back this up a little bit, if I would write this as 2x cubed, let's say I'm going to call this x minus 2, I'm going to say is y. I'm just going to replace it with a y. And then I have minus 10x, and then instead of x minus 2, I'm putting a y. I want to make sure we're understanding what I'm doing. If I asked you to pull out a GCF from that, what would you tell me? Forget the 2x part, because that kind of fell into here. But like, so do you see how the y is common? So if I pull out the y, I'd be left with 2x cubed minus 10x. Right? Here's that part. Here's the x minus 2 I wrote as just a y. Because it makes more sense for kids, just like, you understand pulling out a variable. Kids struggle to represent pulling out like that whole parenthesis out front, okay? So me pulling out this x minus 2 as the common factor, that's why I only wrote it once, is the same as me looking at this and just taking out the y. And I only write it once because I factored it out in front. Does that make sense? Are we understanding why I don't write x minus 2 squared? I'm taking the one piece and I'm factoring out in front. Okay? All right, let's try another one. 15. All right, so if I'm going to group the first two and the last two, I can take a what? I could take a 2, but I could take something bigger. I can take a 4 and x squared. Yep, I can take out a 4x squared. Okay, if I take out 4x squared, we're left with just x plus 3. Now, the other thing I want to make sure that we're aware of, when I'm pulling out GCFs from these, I need to pull out a GCF from both. I have to. So what would you take out if nothing was common? 1. I would take out a 1. If there's nothing there, always take out a 1. Because I need there to have that piece there, so when I can pull out the other stuff on my next step. So even if nothing's common, you take out a 1. But in this case, I would take out a negative 1. Otherwise, I'd write plus 1 and then just rewrite the darn thing. Okay, if there's nothing common, it'd just be a plus 1. All right, that'll flip that to an x plus 3. All right, what is the common factor? X plus 3. And if I factor out the x plus 3, what are you left with? 4x squared minus 1. Done? No, that darn. Wait a minute. Let's see if the squares pop up. It's a good thing I like those, right? How does that factor? And we are done. You guys want to try the next one on your own? Yes, yes, of course you do. Try 16 on your own. All right, guys, how are we doing? We ready? All right, group the first two, group the last two. GCF in the first set, we should have taken out an x. We're left with z minus 2. GCF in the second set, you should have taken out a negative y. Left with z minus 2. Your common factor was z minus 2. And then the leftover stuff would be just x minus y. Yay! How'd we do? We're not excited over math. Come on now. This is fun. All right, guys. Oh, it's even beyond that. All right, so the last method, I like this method, but a lot of students don't. And it's because you can't guess and check this. This is either you know the pattern or you don't. Okay, kind of like the quadratic formula, right? You either know it or you don't. Same thing here. There's almost like a formula to it. It's a pattern that you have to be able to see, and that's how you factor. So first thing though, this is called sum and difference of cubes. We need to know what our perfect cubes are. So let's just make our list. That way we have it in front of us so it's easier to recognize. Squares, we have a tendency to recognize. We see them, we know what they are. Cubes, we don't. What's 1 cubed? We're in trouble from the start. 1 times 1 times 1 is 1, not 3. 2 cubed, that's 8. 3 cubed? Remember, cubes is 4 cubed to be 4 times 4 times 4, which is 64. 5 cubed is 125. Calculator. Yeah, 216. 7 cubes. 512. 9 cubed. And 10 cubed. That's 1,000. All right, guys, I don't expect you to memorize the list. You have a calculator. You can create the list at any time. However, I want you to start to recognize those numbers. Do you know how to find the cubed root in your calculator? We know where the square root button is. Where's the cubed root button? All right, so on your calculators, guys, real quick, I want to make sure we're clear on how to do this. If you hit the math button, it is right underneath the green one. Look at math, and then do you look down to option number 4? You can either arrow down and hit enter, or you can literally just hit the number 4. And then it brings up the little cubed root symbol that you can then type in your number. Okay? So hit math 4, and that brings up your cubed root. And then you can type in whatever number you want. So type in one of the perfect cubes, and then just make sure you see how it works. Okay. Math 4. All right, so guys, now with difference of squares, it had to be what sign in between? Difference of squares, my favorite, had to have what? Had to have a negative in between. Difference meant minus. Guys, this is the pattern that you cannot guess and check your way through. Danny, put your phone down. All right, so for this one, it is sum or difference of cubes. It can be a plus sign or a minus sign. Doesn't matter, which is nice, okay? It does not matter on the sign. So for all of these, though, so if you guys look, it is 2 terms. Just like difference of squares was 2 terms, this is 2 terms. Both terms are going to be perfect cubes. Just like difference of squares, both terms were squares. But this one can be a plus or it can be a minus. It does not matter. Okay? Now, first thing I always have you fill in are your signs. Now, the word soap is how you remember this. Right? You should always use soap when you go to the bathroom. Nothing worse than going to the bathroom, not after you're done with the bathroom. Right? Like you go to the bathroom here at school, nothing worse than you're in a stall and you hear somebody come out and then walk out. That's disgusting, right? That's why you use a paper towel to open the door, because that is gross. Way gross. Okay? Always use soap. All right. So the soap, though, what it stands for, same sign, opposite sign, and then always positive. It shouldn't be. I got highlight happy. That S should not be highlighted. Sorry. I got a little happy highlighting. Yeah, sorry. So sad. So same sign, opposite sign, always positive. That's what that stands for. So what that means, guys, pay attention. Your signs, Lou, Ruben. Your signs. So the same sign as the original problem is the first one. Same sign. And then it flips to the opposite of whatever that was. So that's why it's minus. And then the last one is always positive. So again here, same sign as the original problem. Same. Then it flips to the opposite. And then it is always positive. So same, opposite, always positive. Okay, so that's your signs, and then filling in the numbers. The way this factors is different than anything we've ever factored, because you're going to have 2 terms in the first one, and normally we have like 2 and 2, right? That's the way it always are. But this one actually has 3 pieces in the second one. Different, yay! Right, so we're filling in signs. Same, opposite, always positive, right? Use your soap. There we go. All right, and then filling in your numbers, the first part will just be the cubed roots. Just like before we did square roots, right? If it was 100, you did 10. If it was x squared, you put an x. You just did the square root. Same idea, I'm just going to do the cubed roots. Math 4, right? That's your buttons. And then, to get the second part, I don't care about the original problem anymore. This second part comes from the first part. You will square the first term. So whatever that first number is, you square it. Then you multiply these 2 numbers together, a and b, a times b. And then you square the last one. So it's square, multiply, square. Square, multiply, square. Square, multiply, square. Got that? Destroying my board. All right, let's play with some numbers. So number 17, 27x cubed minus 8. Is there a GCF? No, nothing goes into all of that. All right, so I'm looking at that. So at this point in the game, you have to stop and think, okay, is it my regular factoring that I've always done? And there's not an x squared up there, so it's not. Is it quartix? Is it x to the 4th? It is not. Does it have 4 terms? Is it factored by grouping? It does not. So then I'm like, okay, it's 2 terms with an x cubed. X cubed. It's your sum of difference of cubes. Okay, this is your SOAP pattern. So let's set up our parentheses. The second parenthesis is a little bit bigger because it actually has 3 terms in it. It's the first time we've ever seen that. Right? We will use SOAP, meaning the same sign as the original problem goes in the first one. That is your same. And then opposite, the opposite of minus is plus. And then the AP stands for always positive. That last one is always positive. Okay? Then you are filling in the numbers. So you will do the cubed root of both parts. What is the cubed root of 27x cubed? What's the cubed root of 27? It is 3. And the cubed root of x cubed is x. Again, if you're not sure on your cubed roots, you have a calculator in front of you. Math 4 brings up your cubed root, and then you can type the number in. What is the cubed root of 8? 2. There's the first part. Okay, you see how this is not a guess and check possibility, right? You have to know the pattern. And then it's going to be square, multiply, square. So you will, I don't care about the original problem anymore. I don't like it. Done. Use the first one. What is 3x squared? What's 3x times 3x? 9x squared. And then you multiply them. What's 3x times 2? Notice I didn't care what the sign was. Why don't I care? I already put all my signs in. I put them in from the beginning, so I don't have to worry about it. But 3x times 2 is 6x. And then square, you square the last one now. What's 2 squared? It is 4. And that is factored. This part here, I need to make sure you are aware, it will never factor further. Never. It will never factor further. Because everyone looks at that and they're like, oh, yeah, it's like ax squared plus bx plus c. I should factor that further. And you're like, yeah, I can do that, right? It doesn't. I promise you, it will not. Just Siri, will that factor further? No. Olivia, will that factor further? Nate, will that factor further? Carson with a K, will that factor further? Never, 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 never. Good choice of words. Corbin, will this factor further? Are you sure? Should I try? No. No! Here's what people do. They're like, yeah, I can factor that. Don't write this down. They're like, yeah, my signs are plus. They're like, yeah, I'm going to go 3 and 3. So 3x, 3x, and 2 and 2. That should work, right? It looks great. Try it. That gives you 6x. That gives you another 6x. That does not make 6x. All right? It does not work. Will not factor further. I'm going to be as obnoxious as I can about this, and you know what? Somebody in here is going to try to factor that further. They're the ones who aren't paying attention right now, like Mario. Staring off into space. He's just totally going to try to factor that further. Got his attention, didn't I? When we solve them, we will. Smart girl. Guys, real quick, just because I want to draw attention to Carrie, very genius moment right there. She said, would I use the quadratic formula? If that doesn't factor further, tomorrow when I ask you to solve, you're going to have to use the quadratic formula to solve that. Never fear, I'm a lazy mathematician. I have options for you tomorrow, okay? All right, let's take a look at 18. 125x cubed minus 1. Is there a GCF? No. Do we see how this is a sum and difference of cubes? Two terms, are they both perfect cubes? Yes, they are. So when we set this up, start with our parentheses. The second one's a little bit bigger. What's the word I need to remember to use? Soap. Always use soap. This gets referred to as the soap method all the time because people just remember the word soap. Don't be that person in the bathroom who's walking out and you're in the stall like gagging because they just did not wash their hands. All right, so same. What's my first sign then? Minus. It's the same. Minus. And then opposite is a plus, and then always positive. Okay? All right, how do I fill in these first numbers? It's not 125. Math 4, right? Yeah, so we're going to do the cubed root of both of these, or hit math 4. That becomes 5x. And then the cubed root of 1 is 1. And then it is square, multiply, square. Got to know the pattern. Good. So we square the first one. 5x squared is 25x squared. And then you multiply them together, which is just 5x. I don't care about the signs. I already filled those in. And then I square. 1 squared is... Should I factor that further? Who said yes? Guys, I'm lazy. Be lazy like me. It's never going to factor further. Don't try. Don't waste your time. All right. Why don't you guys try number 19 on your own? All right, guys. Let's see how we did. So these should these be fast? Yeah, they should be, right? Unless you did it wrong. All right, so filling in your signs. Again, we use soap. Always use soap. So same sign. Apparently, I'm not clear enough for all of you. Same as the original problem. Same sign. Opposite would be a minus. And then always positive. That's where you should start. Some of you started just by filling in numbers. Put your signs in first. Get those done and right out of the way. All right, then we do the cubed roots of both of these. So the cubed root of 8x cubed is 2x. Cubed root of 1 is 1. Okay, at this point, I don't care about the original problem. We've moved on to square, multiply, square. 2x squared is 4x squared, because 2x times 2x is 4x. Multiply 2x times 1 is 2x. And then square, what is 1 squared? Is 1. Right? So you are squaring, multiplying, squaring. First one, both, the last one. Ooh, should I factor that further? No. It will not factor further. I'm just going to tell you now, on a quiz or test, if you try to factor that further, I'm calling you out in front of the class. Everybody got that? I am calling you out. That will not factor further. Will not factor further. Samantha, that will not factor further. Yes, Samantha. What? All right, number 20, last one, guys. GCF? No. But if there is one, should I take it out? Yes. If there's a GCF, take it out. There isn't one, but I'm going to keep going here. So we use soap. So what's my first sign? It's a plus. It is the same. And then opposite and always positive. Guys, last problem. Hang with me. We're almost there. All right. From there, we will take the cubed roots. Cubed root of x cubed is x. And the cubed root is 7. Do I care about the original problem anymore? No. I got what I needed from him. I'm moving on. All right. Square, multiply. I sound like a terrible person when I say it that way, didn't I? I took what I needed. I'm out of here. Moving on to somebody else. All right. Square the first one. X squared is x squared. That was not a trick question. Multiply x times 7. And 7 squared is? Marissa, will this factor further? Marissa, will this factor further? It will not. If you want to waste your time, by all means. You must have more time on your hands than I do. Yes? If you put what? What? What does that have to do with anything? Wow, that sounds disgusting. I would not do that.